Welcome to Astronomy Daily, your source for the latest news and discoveries in space exploration. I'm your host, Anna, and today we have a packed episode covering exciting developments from NASA's Curiosity rover on Mars, recent rocket launches, stunning observations from the Webb Space Telescope, a terrifying cosmic scenario involving black holes, and updates on NASA's Artemis program. So, let's get into it. NASA's Curiosity rover has made a groundbreaking discovery on Mars that's sending ripples of excitement through the scientific community. Researchers analyzing pulverized rock samples inside the rover's onboard laboratory have detected the largest organic compounds found on the red planet to date. The findings, published in the Proceedings of the National Academy of Sciences, reveal that Curiosity's sample analysis at Mars Minilab identified 3 significant organic molecules: decane, undecane, and dodecane. These aren't just any compounds. They contain 10, 11, and 12 carbon atoms respectively, making them substantially more complex than previous organic molecules discovered on Mars. Scientists believe these compounds are fragments of fatty acids that were preserved in the Martian rock samples. This is particularly significant because on Earth, fatty acids are among the fundamental chemical building blocks of life. They're essential components in cell membranes and serve various biological functions in living organisms. While the discovery doesn't prove the existence of past or present life on Mars, it does suggest that organic chemistry on the red planet may have advanced further than previously observed. The size and complexity of these molecules indicate that Mars may have once had conditions suitable for the kind of prebiotic chemistry that could potentially lead to life. What makes this discovery even more remarkable is that it demonstrates these complex organic compounds can survive Mars's harsh surface conditions. The planet's surface is constantly bombarded with radiation and oxidizing chemicals that would typically destroy such delicate organic molecules over time. The fact that Curiosity found them intact suggests that if biosignatures ever existed on Mars, they might still be detectable today. This discovery is particularly exciting because fatty acids are fundamental chemical building blocks of life as we know it on Earth. In living organisms, these compounds play crucial roles in forming cell membranes, the protective barriers that separate cellular contents from the external environment, as well as storing energy and facilitating other essential biological processes. As Caroline Freycinet from the French National Center for Scientific Research put it, our study proves that even today, by analyzing Mars samples, we could detect chemical signatures of past life, if it ever existed on Mars. That's a profound statement about our increasing ability to address one of humanity's most fundamental questions. Are we alone in the universe? Turning our telescopes skyward now, this has been an exceptionally busy week for orbital launches around the world. SpaceX kicked off the action with a classified mission on Monday, continuing their breakneck pace of operations for 2025. The European space industry is making history this week with Isar Aerospace attempting the first orbital launch of a European rocket from continental Europe. After a scrub on Monday due to unfavorable winds, their Spectrum rocket is now positioned to make the inaugural orbital launch from Norway's Andøya spaceport. This 2-stage vehicle stands 28 meters tall, with a 2-meter diameter, and can deliver up to 1,000 kilograms to low Earth orbit. What makes Spectrum particularly notable is its propulsion system: 9 3D printed Aquila engines on the first stage, burning liquid propane and oxygen, offering what the company calls the highest density specific impulse of all carbon fuels. Meanwhile, Firefly Aerospace is preparing for the 6th launch of its Alpha rocket from Vandenberg Space Force Base in California. This message in a booster mission will carry a technology demonstrator for Lockheed Martin's LM-400 satellite bus. The launch marks the first of up to 25 flights for Lockheed Martin as part of a multi-launch agreement spanning the next 5 years. Not to be outdone, Rocket Lab is on track for its 3rd Electron launch in just 2 weeks, a remarkable achievement in rapid launch cadence. Their mission, colorfully named Finding Hot Wildfires Near You, will deploy 8 satellites for OroraTech's thermal imaging constellation, which monitors wildfires globally to support faster response times for protecting forests, communities, and critical infrastructure. with 4 worldwide orbital launch attempts scheduled for Wednesday alone, including a Chang'e 3B/E launch from China carrying an unknown payload, and 3 SpaceX Starlink missions planned for the week. We're witnessing a truly unprecedented era in space access and utilization. SpaceX continues to redefine what's possible in the commercial space industry, shattering records left and right in 2025. Just last week, they achieved a remarkable feat when Booster B 1088 set a new first-stage turnaround record of just over 9 days during the NR 57 mission from Vandenberg. This dramatically improves on their previous record of 14 days, showcasing the company's rapidly advancing reusability capabilities. The records don't stop there. At Space Launch Complex 40 at Cape Canaveral Space Force Station, SpaceX established an impressive pad turnaround milestone on March 15th. The Starlink Group 12 16 mission launched just 2 days, 8 hours, 59 minutes, and 40 seconds after the previous Starlink mission from the same pad, slashing nearly 6 hours off their previous record. Perhaps most impressively, this launch marked SpaceX's third mission in a mere 12.5 hours, following the Crew 10 and Transporter 13 missions. While SpaceX has slightly revised its annual launch target from 180 to 170 missions due to some challenges with booster recovery and increased refurbishment times, they're still on an extraordinary trajectory. They've already completed 38 launches across their fleet in just the first quarter of 2025, putting them well ahead of pace to exceed their revised goal. This relentless cadence is transforming our access to space. With Falcon 9 now firmly established as the workhorse of the commercial launch industry, SpaceX is demonstrating that rapid, reliable, and reusable space transportation isn't just a futuristic concept, it's today's reality. The implications for satellite deployment, space station resupply, and potentially even human spaceflight beyond Earth orbit are profound as launch constraints continue to fall. Let's get a JWST update. NASA's James Webb Space Telescope has gifted us with another breathtaking image that's forcing astronomers to rethink what they thought they knew about a cosmic phenomenon. What was once dramatically dubbed the cosmic tornado by NASA's Spitzer Space Telescope back in 2006 has been revealed to be something even more fascinating, a chance alignment of 2 completely unrelated objects separated by unfathomable distances. The Webb's extraordinary resolution shows that what we're actually seeing is Herbig Haro, 49/50ths, a frothy-looking outflow from a nearby young star, perfectly aligned with a colorful spiral galaxy located hundreds of millions of light-years in the background. It's like capturing a photograph of a leaf blowing in the wind that just happens to perfectly frame a distant mountain peak. This composite image combines data from Webb's near-infrared camera and mid-infrared instrument, providing unprecedented detail of this dynamic region. The arc-shaped features in the outflow point back to their source, likely a protostar known as Cedarblad 110 IRS-4, a young object only tens of thousands to 1,000,000 years old that's still gaining mass. What makes this discovery particularly striking is how it illustrates the 3-dimensional nature of our universe projected onto the 2-dimensional plane of the night sky. When we observe space, objects that appear to be interacting might actually have no relationship whatsoever, separated by vast cosmic distances. HH 49/50ths is relatively close to us, residing in the Chameleon 1 cloud complex just 625 light-years away, practically in our cosmic backyard. Meanwhile, the spiral galaxy that appears to be at the tip of this outflow is incredibly distant, with no physical connection to the nearby stellar jet. Over thousands of years, as the edge of HH 49/50ths continues to move outward, it will eventually appear to cover up the distant galaxy entirely, further changing this chance cosmic alignment. Herbig Haro objects like HH 49/50ths are among the most dynamic and visually striking phenomena in star formation. These glowing nebulae form when newborn stars eject high-velocity jets of gas that collide violently with the surrounding interstellar medium. The process is rather dramatic. As a young star forms from a collapsing cloud of gas and dust, not all material falls directly onto the protostar. Instead, some gets channeled into these powerful focused jets that blast outward from the star's poles at astonishing speeds, often hundreds of miles per second. When these jets slam into the relatively calm gas around them, they create shock fronts similar to sonic booms in Earth's atmosphere. These shock waves compress and heat the gas to thousands of degrees, causing it to glow brightly across multiple wavelengths. As the superheated gas gradually cools, it emits light that we can detect in both visible and infrared spectrums, creating the distinctive glowing features we observe. What makes Webb's observations particularly valuable is the telescope's unparalleled infrared sensitivity and resolution. Previous observations couldn't capture the intricate details we're now seeing. Webb can clearly trace the location of glowing hydrogen molecules, carbon monoxide, and energized dust grains as the protostellar jet impacts the surrounding region. These fine-scale observations allow astronomers to model the properties of the jet with unprecedented accuracy. In a concerning discovery, astronomers have detected an erupting supermassive black hole producing enormous jets bursting from a spiral galaxy similar to our Milky Way. The galaxy, known as J2003-450-449, is 3 times the size of our galaxy and located 947 million light-years away. Yet it's causing quite a stir in the astronomical community due to its unusual characteristics. What's particularly alarming about this finding is the scale of these jets. They stretch an astonishing 6 million light-years in length. To put that in perspective, our entire Milky Way galaxy is roughly 100,000 light-years across, making these jets 60 times longer than our galaxy's diameter. While larger jets have been observed in the past, including one named Porphyrion, stretching 23 million light-years, such massive emissions have typically been associated with elliptical galaxies, not spiral ones like J2003-450-449 and our own Milky Way. Perhaps even more puzzling is the fact that J2003-450-449 appears remarkably tranquil, despite housing one of the most violent supermassive black holes ever seen in a spiral galaxy. The galaxy has somehow managed to maintain its spiral structure, including its distinctive arms, bright nuclear bar of stars, and stellar ring. This directly contradicts previous scientific models, which predicted that such powerful jets would tear apart the structure of a spiral galaxy. Adding to this cosmic mystery, J2003-450-449 contains 10 times more dark matter than our Milky Way and is surrounded by a huge halo of superheated gas. In most galaxies, this gas would be cooling and condensing to form new stars. However, in J2003-450-449, the central black hole acts as a cosmic furnace, heating this gas halo and preventing star formation while producing intense X-ray emissions. As one scientist involved in the study put it, this discovery forces us to rethink our understanding of galactic evolution and how supermassive black holes grow and shape their environments. It raises profound questions about what this might mean for the future of galaxies like our own Milky Way. This discovery raises a chilling question that has astronomers concerned. Could Sagittarius A star, the supermassive black hole lurking at the center of our own Milky Way, experience a similar eruption? The possibility is both fascinating and terrifying. While Sagittarius A star is significantly smaller than the black hole in J2003-450-449, just 4.3 million solar masses compared to the distant galaxy's estimated 1.4 billion solar masses, size isn't the only factor determining a black hole's activity. Currently, our galactic center's black hole is remarkably quiet. If Sagittarius A star were a human, astronomers estimate it would be as if it sustained itself on a single grain of rice every million years. That's an extraordinarily modest diet for such a massive cosmic object. But this peaceful state could change dramatically and with little warning. If Sagittarius A star were to capture a large gas cloud or even an entire star, an event astronomers call a tidal disruption event, it would suddenly have an abundance of material to feed on. As this stellar material falls toward the black hole, it would form a rapidly spinning accretion disk, and some of this energy would be channeled into powerful jets erupting from the black hole's poles. The consequences of such an eruption would depend largely on the jet's orientation and strength. If one of these jets, originating from 27,000 light-years away at our galactic center, happened to point directly at our solar system, the results could be catastrophic. The high-energy particles and radiation within such jets have the potential to strip away planetary atmospheres, including Earth's. the intense radiation could damage DNA in living organisms, dramatically increasing mutation rates across all life forms on our planet. In a worst-case scenario, where Earth takes a direct hit from such a jet, the high-energy particles could severely degrade our protective ozone layer, potentially triggering a mass extinction event similar to those seen in Earth's geological record. On a more hopeful note, NASA continues to make progress on its Artemis II mission, which will be the first crewed flight of the Artemis program since its inception. Late Saturday night, technicians at Kennedy Space Center in Florida reached a significant milestone when they successfully moved the core stage for NASA's second Space Launch System rocket into position between the vehicle's two solid-fueled boosters. Working inside the iconic Vehicle Assembly Building, which stands an impressive 52 stories tall, ground teams used heavy-duty cranes to first lift the butterscotch orange core stage from its cradle. The operation required meticulous precision as the cranes rotated the massive structure vertically before disconnecting one of the cranes from the bottom of the rocket. The Boeing-built core stage is truly a marvel of engineering. Weighing approximately 94 tons and measuring about 212 feet tall, this massive component will contain 730,000 gallons of cryogenic propellant when the rocket lifts off. It represents the single largest element for the Artemis II mission. Once positioned, teams connected the core stage to each booster at forward and aft load-bearing attach points. The next steps in the assembly process will include stacking a cone-shaped adapter on top of the core stage, followed by the rocket's upper stage, another adapter ring, and finally, the Orion spacecraft that will house the four-person crew during their journey. This mission represents humanity's return to deep space exploration, as Artemis II will ferry 4 astronauts around the far side of the moon. If all continues according to plan, this historic flight could launch as soon as next year, marking the first time humans have ventured beyond low Earth orbit since the Apollo era ended over 50 years ago. Despite being years behind schedule, the Artemis program continues to gain momentum. NASA has achieved several important milestones recently, including the installation of the Orion spacecraft's solar panels and completing the crucial closeouts of its service module with aerodynamic panels that will jettison during launch. A few months ago, there was serious speculation that NASA's Space Launch System might face cancellation due to its high costs and delays. However, this possibility seems increasingly unlikely as alternative heavy-lift vehicles aren't ready for human spaceflight. Both SpaceX's Starship and Blue Origin's New Glenn, while promising, are still years away from being certified for crewed missions. Starship, though holding enormous long-term potential to be cheaper and more capable than SLS, has faced recent setbacks with back-to-back failures early this year. The vehicle needs to demonstrate reliable recovery, reuse, and in-orbit refueling before it can be considered for human missions. Similarly, Blue Origin's New Glenn had a successful debut flight in January, but its development timeline suggests it won't be ready for crewed flights anytime soon. These circumstances have created a situation where, despite its delays and budget overruns, the Space Launch System remains NASA's only viable option for sending humans beyond Earth orbit in the near term. This practical reality, combined with the progress being made on hardware assembly, makes it increasingly likely that NASA will proceed with Artemis II as planned, marking humanity's long-awaited return to deep space exploration. That wraps up today's episode of Astronomy Daily. What an incredible journey through our cosmic neighborhood we've had today. From the tantalizing discovery of complex organic molecules on Mars that could point to ancient life, to the terrifying potential of galactic-scale black hole eruptions, to the steady progress of humanity's return to the moon, the universe continues to both inspire and humble us. I'm Anna, and I've been your host for Astronomy Daily. If you enjoyed today's episode, you can listen to all our back episodes at astronomydaily.io, where we maintain a complete archive of our broadcasts. And don't forget to connect with us on social media. Just search for Astro Daily Pod on Facebook, X, YouTube Music, Instagram, and TikTok. Thanks for joining me on this cosmic journey. I'll see you again tomorrow as we continue to explore the wonders of our universe together. In the meantime, keep looking up.